Okay students, so this is how the quadrature amplitude shift keying receiver or the demodulator will look like. Let us quickly go through the functioning blocks belongs to this QASK demodulator or the QASK receiver. So first, as you can see, this S of t represents the transmitted QASK signal which was generated by QASK transmitter, which consists of even and odd sequence along with cosine and sine carrier. So which exactly equals to AE of t into root PS cos of 2 pi f naught t plus AO of t into root PS sine of 2 pi f naught t. Now in case of this demodulation part, what we need to do, we are supposed to reconstruct the original symbol sequence which was given to input of this QASK modulator, right? So that symbol sequence is nothing but what? The bipolar symbol sequence which we are supposed to reconstruct with the help of this QASK receiver. So let us quickly go through. The first block represents what? It will try to enhance the power level of this received symbol sequence by an amount of 4 before it is being given to this filter whose name is nothing but what? The band pass filter. The function allocated to this band pass filter is to reject all the higher frequencies apart from this 4f0 or 4f0. It is being exclusively tuned to this desired frequency band 4 of f0. So it will reject all the frequency band apart from this 4 f0. And see, as this is the coherent detector, right? So what kind of role is being allocated to this frequency divider network by an amount of 4? When these signals are being passed through this frequency divider network, so as this is the coherent detector, so we are supposed to regenerate the sine and cosine carrier which was used by that QASK modulator or the QASK transmitter, right? So the output of this frequency divider network will be what? The coherent carrier signal in terms of cosine and sine carrier, because as these two signals are in quadrature phase with each other, once these are being generated by this frequency divider network, furtherly these two signals are being given to this what? These two multipliers, because similar to the transmitter, as we had generated the even sequence and the odd sequence, we are supposed to reconstruct that even and odd sequence. So similarly we used to have the two different correlators, right? Correlators in upper part and correlator in lower part, right? The combination of this multiplier and integrator is nothing but what? Correlator. So in order to successfully reconstruct, the samples belongs to even sequence and the samples belongs to odd sequence, right? So as you can see that these two inputs of this signal multipliers are nothing but what? One input is nothing but this received symbol sequence which consists of even and odd sequence along with sine and cosine carrier, and the lower input is nothing but what? The cosine and sine carrier, those are being generated by this frequency divider network, means it will try to suppress this carrier signal, right? So in this way the output of this multiplier is being given to this upper and lower integrator, which will try to integrate this multiplied symbol sequence over a symbol duration of ts second, right? Where as we know this is the 4-bit QAM or the 16 QASK technique, in which we can have the 16 different symbols, and each and every symbol consists of these 4 binary bits in terms of 1s and 0. So the symbol duration which exactly equals to 4 times of bit duration, right? 4 times of TB. So during this interval, that multiplied symbol sequence is being integrated by this integrated by these two integrators to generate the desired samples belongs to even and odd sequence, because after that it is being given to this analog to digital converter block, which will try to convert this continuous amplitude and discrete time signal into discrete amplitude and discrete time signal to generate these successive 4 bits starting from BK to the BK plus 1, BK plus 2 and BK plus 3, right? So we need to recall this QASK transmitter will try to produce these 4 different bits once after every ts second, right? So out of that 4 bits, first 2 bits belongs to the even sequence and the last 2 bits belongs to odd sequence. So BK and BK plus 1 produced by the upper correlator, and BK plus 2 and BK plus 3 is being produced by lower correlator. After that it is being given to the parallel to serial converter, because as I told you earlier, our ultimately aim is to, we should have to successfully reconstruct the original symbol sequence which was given to the QASK transmitter. So in this way, the binary bit sequence denoted by this B of T is being reconstructed with the help of this QAM demodulator, or we can say that QAM receiver. So this is all about this quadrature amplitude shift keying, or we can call it as a 4-bit QAM or the 16 QAM modulation technique. Thank you.